Machine learning makes predictions every single day, but not all predictions are the same. Today, we're breaking down two of the most fundamental ideas in supervised learning: regression and classification. Both regression and classification are types of supervised learning. That means we train a model on labeled examples, data where we already know the right answer, so it can learn to make predictions on new, unseen data. The model takes an input, processes it, and produces an output. But here's the key question that separates these two techniques. What kind of output are we predicting? First up, regression. Regression predicts a continuous number, a value that can fall anywhere on a scale. Think about predicting a house's price based on its size. As size goes up, price tends to go up too. The model learns a line, or curve, that fits this relationship as closely as possible. That's the equation you see here. Y hat equals W times X plus B. A weight, a bias, and a prediction that can be any real number. Regression shows up everywhere. Forecasting stock prices, predicting tomorrow's temperature, or estimating someone's age from a photo.
Now let's flip to classification. Instead of predicting a number, classification predicts a category, a discrete label from a fixed set of options. Take spam detection. Every email either belongs to the spam bucket or the not spam bucket. There's no in between. The model learns a decision boundary that separates these classes as cleanly as possible. Anything that falls on one side gets one label. Anything on the other side gets a different label. Classification powers a huge range of applications. Diagnosing disease as positive or negative, recognizing objects in an image, or judging whether a review is positive, negative, or neutral. Whenever the output is a category, not a number, you're doing classification. So how do these two really compare side by side? Regression outputs a continuous number, like a price of $432,000. Classification outputs a discrete label, like spam. Regression typically uses algorithms like linear or polynomial regression. Classification leans on logistic regression, support vector machines, or decision trees. And because the outputs are different, we measure success differently too. Regression is evaluated with metrics like mean squared error or R squared. Classification is evaluated with accuracy, F1 score, or AUC.